Hello students, welcome to Edunguru. I call this fondly as the Mathemagic Show. If you are wondering why I call it so, it's because in this show we try to enliven mathematics. We try to ensure that mathematics no more remains dry and boring. It becomes a very interesting subject. And not only that, we also try to ensure that you get good marks. If that assures you, let's begin our journey of mathematics of class 10th. Today's chapter is one of the most fascinating chapters you will ever study in mathematics, and that is on numbers. To be more precise, real numbers. But before I begin the journey of today's chapter, let me also try to know how much you recall a similar journey on numbers that you did in class 9th. In class 9th, you have read about rational numbers, isn't it? Yes, do you all remember? That's right. Let me begin by asking, let's say, Ankit, what do you remember about a rational number? Our topic of discussion today is not exactly on rational numbers, but yes, I would like to test a little bit as to how much you remember about rational numbers. Yes, Ankit, carry on. What is rational number?
A rational number is something which we can express as a upon b.
Good attempt. It's not 100% correct, but nonetheless, he made a good attempt. What is rational number? Rational number is a number which can be written in the form of a upon b. In the form of a upon b, where a and b are integers and they are not decimals or fractions or something like that. That's what is a rational number. Okay? Well, let's do one thing. Let's now begin our journey of this chapter with this background. Today's session begins with the word lemma. So, the word is lemma, L-E-M-M-A. What is a lemma? A lemma is a proven statement used for proving another statement. So, that's what is a lemma. If you look at the idea of lemma, it is very fundamental to science and mathematics, because the entire structure or the superstructure of mathematics and science has been built on some very fundamental ideas. What has happened in history is that depending on those or based on those fundamental ideas, we have built the entire structure of science and mathematics. What we do by using a lemma is that we use one lemma to prove another, and from that we propagate it to yet another, and so on. The process of learning new things or gathering new knowledge goes on in this fashion. Okay? Now, today we are going to begin by discussing what is called as Euclid's division lemma. Now see, division is something that is not new to you. You have divided small and big numbers right from probably class 2 or 3 or 4 also. In fact, today you are in a position to divide many different types of numbers, in fact including algebraic quantities as well, isn't it? At that time, we did not focus so much on the technicality of division, we were more focused on the process of division. So, you learned that to divide, we draw something, we put a number inside it, then we put something else outside it, then we use the tables, and then the process goes on. I am not elaborating so much because it is something that we have done so many times that it would be a waste of time going through the entire process. Let's look at a different aspect of the same process. And that's what today's discussion is on, and that is Euclid's division lemma. So, what is Euclid's division lemma? Euclid's division lemma goes like this: for any two given positive integers, mind you, positive integers, let's call them as suppose a and b, there exists unique whole numbers. Mind you, somewhere I am saying integer, somewhere I am saying whole numbers. So, be clear about that. Let's call them as Q and R. So, there exist unique whole numbers Q and R such that I can write a relationship, and that is A is equal to B Q plus R. So, the relationship would be like this: A is equal to B into Q plus R. Let me describe what these alphabets stand for. A is the dividend. I hope you remember these terms, and even if you don't remember those terms very nicely, don't worry, I will describe them for you as well. Let me first complete the lemma, or the Euclid's division lemma. Now, what is B? B is called as the divisor. Okay? Q, I think you must have guessed by the alphabet itself, Q is the quotient, and finally R is the remainder. So, I have introduced 4 terms, none of them new, you are all aware of these, and if you have by chance forgotten a little bit, don't worry, I am just going to introduce them all over again. So, the terms are dividend, divisor, quotient and remainder. Let me give you a very small example out of this, as you know already. Let us say I am dividing 8 by 3. Okay, I know it is very easy, but then why not go through the process. So, if I divide 8 by 3, I write here 2, 2 into 3 becomes 6, and then you write 2 here, that is what the remainder is. So, in this case 8 becomes the dividend, because that is what is being divided. 3 is the divisor, it is the number by which we are dividing. 2, this 2, now here there are 2 2's, so don't get confused. This 2 is called as the quotient. Sometimes we also call it as the answer, isn't it? And R, which may or may not be always there, in this case is also equal to 2 by chance, and that is the remainder. So, therefore, 8 is the dividend, 3 is the divisor, both quotient and remainder in this case is 2. So, for those who had forgotten a little bit about these terms, I have introduced them as well, isn't it? Let me take a little better example. This was too elementary, isn't it? Let us divide 110 by 7 and relate it to our present theorem. Okay? So, example is 110 divided by 7. The theorem says, or the lemma says, that if you have the number 110, then this will become the dividend, 7 is the divisor, and if such is the case, then you can have a combination of numbers. Now, that is what we will discover a little bit. So, to do that, let me do the division. So, 110 comes here, as we know. So, 7 is out there. Let me go to the first step. So, 1 then get 7. So, first is 11. I put 7 below it. So, the remainder is 4. This 0 comes here. So, it becomes 40. Then I write 5 here in place of the divisor. So, 5 7s are 35, and from 40 I subtract 35 and I get 5. So, what are the numbers? Okay. Let me see. Whom should I ask? Yes, Karishma. Now, in this entire process, tell me which one is the dividend, divisor, quotient and remainder. So, Karishma, start with the dividend. In this entire process, or in this question, which one is the dividend?
Sir, dividend is 110.
Well done, Karishma. Karishma is very right. 110 is called the dividend. Next is Mamta's turn. Yes, Mamta, what is this number 7 called as?
Sir, divisor is 7.
Good. Easy question, I feel. 7 is the divisor. Now, you are left with only 2 options. 15. Yes, Hana, 15 is?
Quotient.
That's right. I think it was a relatively easy one. I am not asking the fourth one because now it is too obvious that 5 is the remainder, and Sana was very correct. 15 was the quotient. Now, the division lemma connects these few numbers like this finally, and that is 110 can be written as 7 into 15 plus 5. 110 is that A, 7 is the B, value of B, 15 is Q, and 5 is R. Now, that is about the division lemma. Okay. Let us take one more example. Let us say if there is a very simple question to start off with. The question goes like this: a number when divided by 8 gives quotient 6 and let us say remainder 3. Okay. Find the number. I will repeat quickly. A number when divided by 8 gives a quotient 6 and a remainder 3. Find the number, isn't it? Now, I know it is a very simple question. I just want you to get in tune with the division lemma. Okay. In this case, what is being asked? Let me write down the division lemma first. A is equal to BQ plus R. What is being asked is the value of A. In such a case, we have to just substitute the relevant values of B, Q, R, and you will get the value of A. Let me do it quickly for you. So, in this case, A is equal to, B, remember in this case is 8. So, let me write it as 8. Q, the quotient here is given in this question as 6. So, 8 into 6 plus the remainder, and that is 3. So, plus R, and that is 3 in this case. So, it becomes equal to 8 into 6 is 48 plus 3, and that is equal to 51. Okay. So, let me now finally connect it by stating and also relating to the division lemma. If you look at mathematically, the lemma says that A is equal to BQ plus 3. So, I am going to write it now finally as 51 is equal to 8 into 6 plus 3, where 51 is A, 8 is B, 6 is Q, and 3 is R, that is the remainder. Okay. Well, that was about division lemma, or you can say more specifically as Euclid's division lemma. Euclid, of course, was one of the greatest you can say mathematician, or to be more precise, geometry inventor, you can say, isn't it? As you know already, you must have read a lot of theorems about Euclid earlier also. Though Euclid is more famous for geometry, but then he has contributed in other areas as well. Well, today I don't want to stretch the session because we have just started our journey. This chapter I would also recommend you to study in historical terms as well, because remember, the idea of numbers is extremely fascinating, and here I can proudly say that even Indian mathematicians of yesteryears, means history, has contributed a lot. In fact, mathematicians openly acknowledge that the concept of zero, which is extremely fundamental to the development of mathematics, was the greatest ever asset, or you can say discovery made in mathematics, and that was done in India. So, we can be proud about that. But then numbers is such a fascinating and wide area that almost entire world you will see some people have contributed from geographically dispersed areas. So, apart from reading the chapter, I would also recommend that you should also read a little bit of the history of numbers. Okay? Our journey has just started. What I would wish and recommend to you is that just solve a few more questions on this simple Euclidean lemma, and before we meet next time, be more comfortable, confident, and also make a little bit of research on this chapter, and I am sure you will generate a lot of interest in this chapter. The rest of the things that are there in the chapter we will be talking about in the next sessions. Till then, enjoy your time, solve a few more questions to get a better idea, and goodbye. In this section, we learnt about the following. Lemma. A lemma is a proven statement used for proving another statement. Euclid's division lemma. For given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where r lies between 0 and b, 0 inclusive but not b inclusive. Here a is equal to dividend, b is equal to divisor, q is equal to quotient, and r is equal to remainder, which means dividend capital D is equal to divisor small d into quotient q plus remainder r. To watch the next video, please attempt the following questions. Question number 1. In a division, the dividend is 24 and quotient is 3. If remainder is equal to 3, find the divisor. Option A, 4. Option B, 5. Option C, 7. And option D, 8. Question 2. In a division, dividend is equal to 17 times remainder and quotient is equal to 4 times remainder. If remainder is equal to 3, find the divisor. The options are option A 5, option B 8, option C 6 and option D 4. Question 3. If divisor is odd and dividend an even number, then the remainder is option A always odd, option B always even, option C even if quotient is odd, and option D is even if quotient is even.